Okay, so I didn't know what level to target like the talk at, and I didn't know like what to like actually talk about, so I just like put together something really quickly, and then hopefully it's interesting for everybody. So basically, the topic of the talk is really databases and a question of like whether or not you're actually using the right database for whatever you're trying to do. So the thing is like everyone, like not everyone, but often people just default to like SQL databases, or they try and put like NoSQL into like a like lump categories, like, oh, NoSQL is like this or like that. But really, NoSQL really just means no tables. And it's like a very, very deep and like wide space that contains, there's probably more NoSQL databases than there are SQL databases. So the question really comes up with, are you really choosing the right like SQL or NoSQL solution for like what you're trying to do? And most of it comes down to like data modeling and how NoSQL databases store your data. So like just really simply, like starting with like, so then there's like there's a document store, right? Which everybody knows. There's like MongoDB, which is awful. There's AWS DynamoDB, which is half awful. And then there's the Cloud Firestore, and then there's Elasticsearch, which is or isn't a database depending on who you ask. And basically, if you think about it, it's like putting your things in a filing cabinet, right? And then in your filing cabinet, your files may or may not be typed. If you're organized, then they'll be typed. If you're not organized, then it turns into like the Wild West. And that's the primary weakness of document stores. But basically, you can file various related or may not be related documents into like a filing cabinet, right? And that's good for some cases. And this is probably the most popular form of NoSQL database that everyone always talks about, right? But then if I move on, then there's this kind of database. Has anyone actually heard of like a graph database before?
Yes.
Okay. All right. Great. So graph databases are very different from your normal database in that they store your data in a directed or a non-directed graph. There is no table. It's a graph. And so everything is like a node, and everything is connected to another node with an edge. And that's basically how your data is. And the examples are like dgraph, Janus Graph, or like AWS Neptune. These are very conceptually hard to use, but they are very good at navigating across tables, right? Or not tables, navigating across like different types of data. Like if you can imagine if it was an SQL solution, to get like all of the posts made by like a certain person, right? You'd have to join multiple different tables to get your result, right? And this will scale in ON time based on the size of your tables, depending on your normalization. But in graph databases, like traversal is constant time. So it can be very, very fast for fetching a lot of related data, much faster than any kind of SQL solution. So, but conceptually, this is very difficult to organize. And if you don't do it right, you can end up in a quagmire. So you should, but this is like a very promising technology. And then, of course, there is another kind of database called a time series database. And this examples are like InfluxDB or Prometheus. And there's no tables, but the idea is that every record in your database is a record of a specific point in time. So your database only goes forward in time, and then everything that happens in that point of time is added to that record. So it's just like a horizontal record of time, and you can label different events in time, but it only progresses forwards. And this is really good for things like metrics or just recording like scientific data. And you can have like a lot more records with different levels of like granularity. Like you can have nanosecond resolution, you can have like microsecond resolution, millisecond, and this is much better than like an SQL database that does this. But all of these are really like specific applications. And then you have this thing called NewSQL, which depending on who you ask is basically Jesus. So examples are like Cloud Spanner, CockroachDB, and then there is one called TiDB, which is actually sponsored by the CCP as a replacement for Oracle DB. But basically what it is like the weakness of a lot of these NoSQL solutions is that you don't have like ACID transactions, right? So you don't have like the typical atomicity, consistency, and like, all that stuff, right? And so NewSQL tries to use like a more flexible storage layer. So in this case, like TiDB uses a bunch of key value stores. And then they have like a database driver built that interprets their key value stores to try and serve you like a familiar looking like MySQL or like SQL driver, without any of the disadvantages of like NoSQL. Anyway, that's it. There's so much more, but that's 5 minutes. Okay, sorry. That's it. Thank you.
Thank you.
Yeah.
All right, now for questions and answers. So if you have a question, please.
I have a question.
Yeah.
Have you used CockroachDB before?
I have.
Is it cool?
It's very cool.
I do.
Um,
What is the fanciest thing you used it for?
I only did a POC with it, but it was very difficult to actually get it running. But it's very, it has much more redundancies than all of the other new SQL solutions. Maybe Google Spanner has something like similar, but Spanner won't tell you because it's proprietary, so you have no clue. But CockroachDB is highly redundant, and then if you have your partition strategy set up properly, it's hard to imagine how it could die. But I don't know. It's computers; they always die.
What about data? What kind of data can you store there?
They have different drivers that you can do, like put on top of it. But essentially, it's not so different from like MySQL.
Oh, okay.
Yeah, it's a table-based record. So like it's just like their goal is to serve you like a MySQL database without any of like the write bottlenecks that you would have from a normal MySQL cluster.
Oh, that's,
Yeah.
thank you.
Is it still ACID?
Is it still what?
Yeah, ACID compliant? Is it still the
Yes, it is. Yeah. Anyway,
Question.
Yeah.
Have you ever used Vitesse database?
I've heard of it, but I haven't used it before. No. Anyway, graph databases are super cool. You should try it.
What's the benefit of the time series databases?
The benefit of the time series database is that you can store a lot more data than you can with a normal SQL database. So if you can imagine like Prometheus, right, is
I
a
know about Prometheus.
yeah. So it's a time series solution, but it allows you to store how should I say it? Like you could store a lot of records from a lot of different systems and a lot of metrics on like various levels of like time resolution.
Yep.
If you tried to store the same thing on like an SQL database, you would just simply die because you had too many rows.
Oh, so you can. It's about the quantity.
Yes, right. So there's no like, I mean, it looks like a table, but there's actually no tables in the time series database. It's a series of like points in time.
So it's big to query as well.
Yeah. So the queries are more or less at constant time, but you are limited to how many points you can fetch at a time based on how much memory you have in your system. Because if you think about Prometheus and all of your systems are reporting like once every like nanosecond, right? And then you tried to fetch like all of the data in 1 second, you would have a lot of data, right? And so the writing is constant time. But fetching is also constant time, but how many points you can fetch at a time depends on how much memory you have.
Okay, awesome. Thank you.
Can I ask one more?
Yeah, go ahead.
Never use a graph database. What is a simple use case for it?
Okay, so a really simple use case for a graph database is something like if you have like a movie database, right? And then you're saying like, okay, so I want to find like this movie, right? And then you find the movie, and then you say, okay, I want to find all of the actors in this movie and all of the movies that these actors were started, right? So then if you were trying to do this query in SQL, you'd have to take the movies table, join it with like an actors table maybe, right? And then join it again with the movies table, right? And then you'd have to like pick the records, right? And then depending on how many records you have, right? This could be a very expensive or a very cheap operation.
I see.
But however, in a graph database, it is simply a matter of traversing like the directed edge, right? And edge traversal is basically free. So you can do, like, I think the primary use case is getting records that require several joins of very large tables very quickly. Yeah. And also you have a visualization so you can find things that are related to each other much more easily in an SQL database. Because you'd have to design your SQL schema in advance for specific queries for performance reasons, right? But in the graph, you model it as a graph, and it like you don't have to like worry about this kind of performance constraint because traversal is constant time.
Okay.
Facebook built their own graph DB, right, when they started.
I think so, yeah. Yeah, like relationship data is very useful for like this kind of thing.
Okay, thank you.
Any more questions? Good. All right. Thank you.
All right.
Thanks.